Hello, my name is Nolan Mera. Today I'll be talking to you about Chapter 9, which is all about correlational research. So the objectives of correlational research today that I'll be talking to you about are to define and state the purpose of correlational research and describe its process, to state the major purposes of relationship studies and prediction studies, and to describe some other analyses and the problems to consider when interpreting correlational coefficients. So here is the simple definition of correlational research. Correlational research involves collecting data to determine if there is a relationship between two variables and how strong that relationship is. So in this example, very simple example, we have variable x and variable y. So we take data over x and data over y and see how related those two things are. As you can see, these two things are pretty related. Um, they have a very strong relationship. The purpose of correlational studies is to test a hypothesis regarding expected results. So, the example here is what is the relationship between reading scores and silent reading time? That is an example of a research question in a correlational study. So, we take them at the same time. We look at, we ask students or observe how often do you read? Um, and how long have you read, and correlate that with a test we give them to see how good their reading score is. The purpose of correlational studies is not to find causal relationships. So it is only able to show the researcher whether two things are related, not whether one influences or causes the other one. This is the process of correlational research. So number one, we have our problem selection. There needs to be some rationale for the variables to be correlated. Avoid fishing. That means avoid finding a bunch of different variables and correlating them all together and seeing which one sticks to the wall. That's fishing. So there needs to be some sort of reason. For example, reading. We know maybe probably when I read, I feel like I'm get better at reading. So there's some sort of rationale for that study. Participant and sample selection is step number two. So usually researchers try to aim for a minimum of 30 participants. That makes the data more rounded and able to be statistically significant. And number three is the procedure. So you're going to obtain two or more scores for each member of the sample. Um, so you have one person. You're going to take their two scores. You're going to take their reading time and their test score. So yep, two scores, and then um, if you have more variables, you can take more of those variables. So, and then you have number four, data analysis and interpretation. So correlate the variables and find the correlation coefficient. We'll get into that, indicating the size and direction of the relationship. So types of correlation, these are represented as R values. You have positive correlation. As one variable increases, so does the other variable. We have negative correlation. As one variable increases, the other variable decreases. So maybe, for example, that is watching TV. Time watching TV may have a negative correlation with your reading scores because it means you're spending probably less time reading. So it's going to have a negative correlation. That doesn't mean that more TV causes worse reading, but it just means that you're not doing another thing. Um, That's one example. And then there's no correlation. So there's no significant relationship between the two variables. So if you can't find a line of best fit, which is what is red in those graphs, um, then there is probably no correlation. So if it's flat, then there's not really a strong relationship. It's kind of just random. the variables are happening randomly. So um, I highlighted out what a strong or moderate R value is going to look like. So closer to either -1 or +1 are going to be your strongest correlational coefficients, and closer to 0 is going to show more of no correlation. So there are two types of correlational studies. One is the relationship study. So relationship studies gain insight into variables or factors that are related to a complex variable. So complex variables, example is achievement. There's a lot of factors that go into achievement. Um, so maybe relationship study is just focusing on one. So find the R value to see what variables have the highest correlation. Help researchers to identify related variables to study in studies that do investigate causes. So if we find a strong relationship, we can use that to um, inform our experimental studies that do find if one causes the other, if X actually causes Y. Um, but even if a study reveals that a relationship does not exist, so if there's no correlation, it shows researchers that it does not need to be studied further. So they can save time for researchers and make sure that when we do the more costly, expensive um, causal studies, that they are well informed. So type 2 is a prediction study. So if two variables are highly related, scores on one variable can be used to predict scores on the other variable. So we have predictor variable, that's usually our x, and we have our criterion, which is our complex variable. So for this example, high school grades are correlated with college grades, and so we can use our high school grades to make a prediction onto high school grades. Um, so some purposes of a prediction study are to help make decisions about individuals or aid in various types of selection. So if you're a college, you want to know how good your kids are going to do or how good the students are going to do when they get to college. Look at their high school grades. Um, but including more variables into the prediction makes it more accurate. So we're going to look at high school grades, and we're also going to look at um, other ACT scores. That's going to give us a higher, another more information. It's going to give us a higher prediction or a more accurate prediction. It's important prediction studies should be reported as a range, so not a single number. So for this example, we have hours studying versus a score on a test. If I study for 5 hours, I'm likely to get an 80 based off of this specific line, but this should be represented as a range. So I might get a 75 to an 80 is the most likely that I'll fall into if I study for 5 hours. So some problems to consider using the proper correlational method. So you should use Spearman-Rowe with a small number, less than 30% or less than 30 subjects, and you use the Pearson R if the sample is large, and that's typically what correlational studies are aiming for. Um, we should be sure that variables are valid and have high reliabilities. So think valid is consistency, but valid is accurate. So reliable variables are consistent and repeatable. Valid variables are accurate and measure correctly. So we want to get closer to that bullseye. Sample size, we want to get closer to the bullseye and hit that bullseye often. Um, so making sure our variables are solid. And then sample size. So large samples require smaller values to reach statistical significance. So even though a large sample is statistically significant, it might be unimportant. So we have to be able to interpret our data based off of our sample size and understand what a good correlation is and statistically if it's statistically significant when we have a large number of subjects. So we have covered correlational research. We've covered what correlational research is. We covered the purposes of correlational research. We covered the process and steps to conduct the research. We covered a little bit of data analysis, including our types of correlation. And we talked about the different types of correlational research, the relationship studies and prediction studies. And then we talked about some problems to consider when we are evaluating and analyzing our data.